All right, here we are. I don't know about you, but I was having issues with Zoom. It was actually not acting well at all. It kept kicking me off and all this and that. So I guess we're okay now. That's good. That would have been a disaster. All right. Well, anyway, so here's what we're going to do today. We're completely done with chapter 5. And so that means it's time to do the problem set number 3. Now, this one's going to take a while. There's a lot of material here. But when we're done with this, you'll be in really good shape when we do eventually one of these days finally get around to having an exam, which is not going to happen anytime soon. So don't panic. We have to still finish this. We have to go through chapter 6 and its problem sets. And then we're going to have a review session for the midterm. When it does finally happen, it'll probably by that time be early to mid-March at the earliest. So in the meantime, we'll just carry on with what we've been doing, and we'll see how it goes. All right. So let's start here with the exponents. So here we've got the product rule. So remember what happens here is when you're multiplying these together, what you're actually doing, because they have a common base, is you are adding up the exponents. Okay, so here you'd have 4 plus 2. And then that would equal 3 to the 6th power. And if you take out your God, these superscripts are kind of a pain on this keyboard. But yes, so 3 to the 6th power, if you take that out your calculator, you'll see that it's 729. Now, as always, there's more than one way of doing this. I've noticed that some people prefer to evaluate them separately. And in other words, you could do 3 to the 4th if you want to, and that would be 81. And then 3 squared is just 9. And you'll see, of course, it's the same thing. So it doesn't specifically say you must do it any particular way. But I personally think that it's quicker and easier to simply use the power rule because you're just adding up the exponents and then you're calculating the result. Here, you've got these 2 extra steps. But that's up to you. It's your decision. All right. You can use whichever approach you're more comfortable with. So like here, for example, we'll have 5 to the 3rd, 3 plus 3 equals 5 to the 6th power. Whoops. And as you can see from looking at your calculator, that's 15,625. But again, if you'd rather do them individually, 5 to the 3rd power is 125. And that, of course, is the same thing. It doesn't make any difference which one you do. All right. Let me boldface these so you can see them a little more easily. All right. Now, how about this one? 4 to the 4th times 4 to the 3rd. So you're going to have 4 raised to the 4 plus 3 power, which is, of course, 4 to the 7th. And that turns out to be 16,384. Or alternatively, you could just say, all right, well, 4 to the 4th is equal to 256. And 4 to the 3rd is 64. And that product is also 16,384. Very good. All right, now, how about this one? 2 to the 6th times 2 to the 4th equals 2 to the 6 plus 4 power. And that, of course, brings me to 2 to the 10th. And so in this case, if you go to your calculator, you'll see that this is equal to 1,032. Or the other option is to go, all right, well, what do we have here? 2 to the 6th is 64. 2 to the 4th is 16. And therefore, that product is 1032, which should come as a surprise to no one. All right, 2 to the 4th. Yeah, that's right. Okay, very good. All right, let's see. Oh, here we go. Oh, you're right. Sorry, that's right. My fault. I was looking at the wrong thing. It is 1024. I'm glad you caught that. I had two different things written down on my paper and I was looking at the wrong one. All right. Okay, everyone. Julia is right. It is 1024. My mistake. Yeah, you do all that work and then you make the dumbest mistakes at the end. It's like, oh my God, it happens, but it's very frustrating. All right. So now this one, we got to watch it. I'll tell you what, you might not, I hope you noticed that there's a little tiny slash in here, which means this is supposed to be a division problem. I've had this problem in the past where the slash isn't necessarily the most obvious thing in the world. And so here it is. This was supposed to be a division problem. So sometimes the problem is like when they get squeezed together like this, maybe it's not super obvious, but these last few are meant to be division. And so we're using the quotient rule here. And so here, for example, you've got 3 to the 4, 3 to the 4 minus 2 power. So since now we're doing a ratio or division, just remember to subtract instead of add because you're dividing. And you end up with 9 here, or else you can think of this as 3 to the 4th, 81 divided by 9, which is just 9. Okay, so either way, you'll get the right answer. Here's another one. It's another ratio. We're using the quotient rule. 6 is raised to the 5 minus 3 power, which reduces to 6 squared, which is, of course, just 36. Or the alternative would be to say, well, 6 to the 5th power is 7776, and 6 cubed is 216. And if you take out your calculator, you can see that ratio does, in fact, equal what we're looking for, which is 36. Okay. And by the way, I want to make it very clear, you're not going to be required to do both of these techniques. You can pick the one you're most comfortable with. But in the past, I found that when I did it with the power rule or the quotient rule, whatever, there were always a few people who preferred to do it the other way, and that's fine. Not a problem. Okay, so here, for example, we have 2 to the 5 minus 4 power. Whoops. 5 minus 4, of course, that's 1. And that reduces to 2. That is very nice. Or the other alternative is to say, all right, well, you know what this means? This is 32 over 16, which is 2. Now, this one is interesting because remember, there's an implicit 1. When you have no exponent, there's an implied 1 there. So you can treat this as a to the 1st power. So when we use the rule, the quotient rule, that is, you can treat this exponent as 3 minus 1, okay, which is equal to 8 squared. And that, of course, that is 64. Or the other option is to recognize that 8 to the 3rd power is 512. Divide that by 8, and you will, of course, get 64. Okay, now get some tricky ones. Now look at these. This one in particular, if you notice, this is not the product rule and it is not the quotient rule. This is the so-called power rule because the 3 is on the outside. So what you've actually got here is 5, and the exponent is not 2 plus 3, it's 2 times 3. Okay, so you've got 5 to the 6th power, which is, let's see, that is equal to 15,625. Oops, 15,625, right? That was just bad typing. All right. Or the other option is to recognize that 5 squared is just 25, and that gets raised to the 3rd power. And that, of course, gives me back 15,625. All right. Now what do we do? Oh, here's another one where we use the exponent power rule. we're going to have 4 raised to the 4 times 2 power, or 4 to the 8th, which is, ooh, that's going to be a big number. We're looking here, ooh, 65, 536. Or, once again, what we could do is evaluate 4 to the 4th first. 4 to the 4th turns out to be 256. Now we raise that to the 2nd power. And once again, same thing. All right, so by this time, I'm assuming that everyone's getting very comfortable with those calculators. Now, here's one you have to watch out for: negative exponents. Make sure you can do this. Now, once again, this is the product rule. So we add the exponents. And that's going to give us 3 to the minus 2 power. Oops. Now here, remember, this equals the same thing as 1 over 3 squared, which is 1 over 9. And if you want to write it as a decimal, you can certainly feel free to do so. This is approximately 0.11111, although it does go on forever. And then the other option would be to put 9. So 3 to the minus 4th is 1 over 81. So you've got 1 over 9, which is the same thing. By the way, I want to show you a little trick here. Yes, if you go to your calculator, this is a side note. If you type in your calculator 3 to the minus 4th power, it's probably not going to give you a nice fraction like 1 over 81. It would turn out to be, yeah, this awful thing, 0.012345 But if you want to convert that to a ratio or a decimal, sorry, a fraction, use the 1 over x key. Now in your calculator, the 1 over x key is found, if you're using the iPhone, of course, it's on the extreme left end of the keyboard. It's the 3rd from the top in the very first column. And if you hit that button, what you're going to get is the fraction. Let's see, hold on one second. Let me just double check this on your calculator. It works on other calculators that I own, which is quite a few. I just want to confirm it right now, just in case it's slightly different. Okay, so you get that number. If you hit 1 over x, there you go. It'll give you 81. In this case, you will get 81, which means that 3 to the minus 4th is not 81. It's actually 1 over 81. Okay, so notice if you wanted to know what the equivalent fraction is, then you just hit the 1 over x key. Now, it may not work out nicely. It isn't necessarily going to turn out into a nice integer, but in this case, it does. And so you see how it made it easier to multiply these out. Not that you would have gotten the wrong answer if you multiplied 9 by this fraction, but still, I don't know, sometimes it makes more sense to use fractions. But if you were wondering about that, this is how you would do it. In other words, how did this get to this? That's how. You never know. These little tricks sometimes can come in handy. Sometimes they're hardly worth the trouble. All right, so here we've got 4 raised to the minus 3 plus 5, which is, of course, 4 squared, or 16. And then, of course, now here, this might come in handy. 4 to the minus 3rd power. If you go to your calculator and use that, you'll get 0.015625. And I'll do this as a side note over here. 4 to the minus 3rd is 0.015625. If you hit the 1 over x key, you'll get 64. So therefore, 4 to the minus 3 equals 1 over 64. So I'll put that in over here. Times 4 to the 5th, which is by itself 1024. And of course, that product will be 16, any way you look at it. Now, by the way, here's another possibility too. If you're not sure about this, all you would have to do is, let's throw this in here, and this is all about just making things a little simpler. You can obtain 4 to the minus third by calculating 1 over 4 to the positive third, because that's what it actually means. And then you'll get 1 over 64. That's another possibility. All right, so again, do whatever makes you comfortable. And of course, make sure you're really getting that calculator down. You don't want to find out on the day of a test that you do not understand your calculator. All right, that's not the time to find that out. Yeah, sure, there's videos on YouTube and there's all the rest, but you don't have time to waste, do you? No. All right. All right, how about this one? There's 2 negatives. What's going on with that one? Not a problem. All you have to do is recognize that this is, again, the product rule. You're actually adding -2 here. So let me write it out like this. But it's clearly equal to 5 to the minus 3 minus 2 equals 5 to the minus 5. And 5 to the minus 5, which you can actually leave it like this, by the way, if you want to, but this is the same as 1 over 5 to the 5th. And 5 to the 5th is 3125. And you can leave it, 3125. And you can leave it like this too, but if you do divide this by 1, it's equal to 0.00032. The other option is to recognize that this is 1 over 5 cubed, which is 125, times 1 over 25, which is 1 over the product of those two numbers, 131.25, and again, that works out to 0.00032. Okay. Now here's an interesting one. We'll see why in a second I'm saying that. Because look what happens when you combine these. You've got 6 to the 3rd. Whoops. And then you've got -3. And you just end up with 6 to the 0 power, which is 1. Interesting. And then if you do it the other way, 6 cubed is, I believe, 216. Let's double check. Yep, 216. And then you're multiplying that by 1 over 216 equals 1. All right, and then just finally one more. Remember, this is division. You're using the quotient rule. 2 to the 5 minus 7. 2 to the minus 2. Or 1 over 2 squared. Okay. Or else you can just recognize that 2 to the 7th is 32. And 2 to the 7th is 128. And you just end up with 1/4, 125. All right, so those were all done. Ooh, that was tough. Look at them all. Yeah. All right, well, now we get to do some scientific notation. Remember how this works. As soon as you see this, you know right away, it's 6.25 times 10 to some exponent. What exponent is it? Well, there's a few ways you can approach this. Like, for example, you can use the approach where you just count. From here, if you shift over 1, 2, 3, 4, 5, 6, 7, 8 places, you'll get the right answer. Okay. Now, the other option is to say, well, you know, this is 625 million, and a million is 10 to the 6th, therefore it must be 10 to the 8th. I don't know what else you can do. If there's something your calculator can do for you or not, I'm going to type it in here and see if there's anything it can do. I'm going to say probably not. It's not maybe that sophisticated. No, I don't think so. But what you can do is double check. When you've finished, you can go to your calculator. Remember that EE button I told you about? You can go to double check. Say this is your final answer. You can go to your calculator and type 6.25 times 10. Now here you get a break because the calculator has this amazing function here, which is called EE. In fact, I don't think you need that multiplication sign. If you do this, 6.25 double E 8 equals, it'll give you what you were looking for, 625 million. The EE means 10 raised to this power. It's basically a shortcut, that's all. All right, so just if you're not sure, you can double check. Now, if you got the wrong answer, then you should be able to figure out why. If it's too small or too big, you should be able to adjust it so you get the right answer. And that works in both directions too, when it's small or large. So here, 9.910, we start out with that automatically. So how many places do we have to shift over? You can imagine this is your 9.910. 1, 2, 3, 4, 5, 6. Okay, so that's 6. And why don't we double check that? Go to your calculator and type 9.910 EE6, and that should, yeah, there it is, 9,910,000. Yes, double checking is always a good move. Even an expert can make mistakes in this stuff. You know, you try to rush it or try to do it in your head. Double checking is always a good way to go. I mean, obviously you don't want to waste all your time with it, but it's a good idea, I think, especially with a complicated idea like this. Now here we're going to need 7.3 times 10 to some negative power. There's a few ways of approaching this one. Let's try this. 1, 2, 3. Okay, 3 places means -3. Or if you note, and this is something that might help you, maybe not, the size of the exponent, forgetting the negative, is 1 more than the number of leading zeros. So here we had 2 leading zeros, which implies -3 here. And again, there's a double check. Now you have to watch it with negative exponents because every calculator is a little different. So we're going to type 7.3 E. But what about that negative exponent? On this calculator, you're going to put 3 followed by that plus minus sign, which is above the 8. That's how this calculator does negatives, okay? And then you hit the equal sign and you'll get exactly what we started out with, which is that. Now I know you're used to putting the negative sign before the number, but that's not how it works on this calculator. It's not that unusual. A lot of calculators are set up this way. The only exception I can think of is the TI-84, where the negative sign does actually come first. But almost all the rest of them, that plus minus sign means switch the sign. That's all it means. And here's another helpful tip. If you need a negative number, do not use the minus sign. You will not get the right answer, okay? Just forget the minus sign. For negatives, use the plus minus symbol. All right, how about this one? Oh, some of these you have to work it backwards. So look how easy this one is. One place, that's it, you're done. 2.61 times 10 to the minus 1. And for your double check, 2.61, EE1, use the plus and minus sign. And that, and equals, don't forget the equals. Okay, one negative, and we're good. Now, going the other direction is easy because you can just type it right into your calculator. You can do it on your own too, but if you type 5.9, and by the way, there is I just noticed it, there's a 10 to the X button here too. I guess I don't know why we need it when we have EE, but just type 5.9, EE4, and see what happens. Oh, here we go, 59,000. How do you like that? It was so easy. And if you're still not sure, I mean, what you could do, if you're absolutely determined to double check it properly, what you could do is say, all right, well, here's what we've got. We're going to move 1, 2, 3, 4 places to the left to get to 5.9. Well, that was pretty sloppy. Let me try that again. Yes, if you're very careful, and you must double check your results. Yeah, that's another possibility. Just shift over and see how far you have to go to reach 5.9. It's not a bad idea. All right, let's try this one. 6.28 EE, whoops, E8, EE, 6 equals, that should do it. All right, 6.28 EE, 6 equals. Wow, look how easy that is. And of course, you recognize that 6, 10 to the 6 is a million. So therefore, that has to be right. 6.28 million. And again, if you want to shift the decimals around, 1, 2, 3, 4, 5, 6. So a shift of 6 places would bring you to 6.28. Now, that's obviously a very informal approach. Mathematicians would probably be horrified if they saw us doing that, but it works. Okay, so let's try this one, 3.75 EE. Now, don't forget about that negative key. Do not use the minus. And so this should give us, let's see, 3.75 EE, 5 negative equals 0.0000. And again, you notice for an exponent of negative 5, there should be 4 leading zeros, which we have here. And that's a tip-off that you've done it correctly. Or you can do the shifting. Okay, in other words, you can go to and just count how many places you have to go to get to 375. 1, 2, 3, 4, 5. And that's what we wanted. All right, so How about this last one? 9, just 9, EE 10 negative equals. So this one's going to be a tiny little number. Nine, look at that. 9 leading zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So for an exponent, negative 10, there should be 9 leading zeros. Okay, and so that will take care of that one. Whoa. All right. Now, these are algebraic operations that we perform with scientific notation. So remember what you're trying to do here. You've got 3 times 2 times 10 raised to the, now remember, we're using the product rule here. So you end up with just 6 times 10. Actually, you could write it 6.0 times 10 to the 10th. If you want to be super crazy technical, we usually try to have at least a single digit after the decimal, even if it's a 0. Now, I think you could pull this off on your calculator too. Let me just double check something here. If you were to type 3 EE 4 equals times 2 EE 6, that should do it. Let me just confirm that. 3 EE 4. Actually, I don't think you need that equal sign, that first one, times 2 EE 6. You do need the last one, though. Oh, look at that. How do you like that? Now, the only problem, though, guess what this is going to do? I just realized this is not going to help you very much, because look what it does. Then you have to convert it back to scientific notation anyway. So maybe you should think twice about this one. You can if you want to. It will work. Okay, 3EE4, I'll double check this, times 2EE6. Yeah, that'll do it. But then you have to convert it anyway. So I don't know. You might find this easier in the first place right here. I think you probably will, as a matter of fact. But it's there if you want it. All right, let's do it that way from now on. Unless you just love to play around with your calculator. I mean, it's possible. It is a lot of fun, isn't it? Yes, it is. You have to admit it, don't you? At least to yourself. Yes, I enjoy this very much. That's right. It's almost as much fun as your TV. No. All right. So this is 40 to the 8th. Now, here's the problem. Remember, our objective is to get this written as 4.0, not 40. So how do we adjust it? So what we're going to be asked to do here is, in order to write this in proper scientific notation, the constant should be 4.0. What exponent of 10 do we need to make this work? So here's what you should think about. To convert 40 to 4.0, we divide by 10. Okay, but if we divide by 10, we're going to change the number. In order to make sure that we don't change the number or change the value of this number, we will then multiply 10 to the 8th by 10. Okay, so in other words, we're going to take this and make the following two changes. We're going to multiply this by 1 over 10. And over here, we're going to have a product with 10. So therefore, we'll have 4.0 times 10 to the 9th power. All right, so in other words, in a case like this, it technically isn't, it's not wrong. It's just that it's not proper scientific notation. So what you want to do is, in order to avoid making mistakes, just visualize what you're actually doing to convert it from here to here. You divided the constant by 10, which means you must multiply the 10 to the 8th by 10. And when you're done, if you take this to your calculator and type it in, you'll see that you will get the same results. All right. Now, some of these are a little bit messier. We're going to have 6.2 times 4.3 times 10. So the exponent will be minus 8. Why minus 8? Because you've got minus 2 and minus 6. In fact, you know, let me do that. I don't want to leave out steps. Yeah, because then you'll look at it later on and say, wait a minute, where did that come from? So just remember that what we're actually doing here is adding together these two exponents. Now, okay, now it's 100% complete. There you go. All right, now we're going to run into that same problem we had before. The constant will be greater than 10. 6.2 times 4.3 is 26.66 times 10 to the minus 8th. But we want it to be 2.666 times 10 to some value. So why don't we write this as 1 over 10 times 2666, 10 to the minus 8th, times 10. We have to multiply and divide. So therefore, we end up with 2.666 times 10 to the minus 7th. Okay, because remember, this is implicitly 10 to the first power, and we're adding their exponents. Well, now, let's see what this one is all about. So the exponents will be minus 5, minus 6. All right, so 1.7 times 3. I don't think that'll go over 10. It's good, there we go. 6.46 times 10 to the minus 11, and we're done. That's kind of nice. When it's completely done in one step, instead of having to make more adjustments, I don't know about you, but I like that. Yes, I do. All right. Now with this one, so we're going to have an exponent of 4 minus 7. (8.8) times 10 to the minus 3. Okay, and that's it. We're done. (2.2) times 3.6 is 10 to the 3 minus 4. All right, so 2.2 times 3.6 is 7.92 times 10 to the minus 1. And that's it. We're done. All right. Let's see what's coming up next. Let's see. Okay, one more of these. Two more, and then we got some divisions. Okay, we have to do those as well. Okay, so here we have, 15. So we're going to have to make an adjustment here to the minus 10. Oh, how unfortunate. All right, so how do we do that? We're going to divide that by 10. So we're going to have 1.5 times 10 to the minus 9th power. By the way, it could go either way. So far, it hasn't worked out the way, but if you ended up with something like this, 0.7 times 10 to the third, then what you would do is multiply this side by 10 and divide this side by 10. Okay, so in other words, that can happen too. It hasn't happened so far, but if you have too small a number on this side, instead of dividing and then multiplying, you're multiplying and then dividing. All right, I just want to let you know, just in case that doesn't happen here. Doesn't look like it. All right, but anyway, one more of these and then we'll do some division. Yeah, I know this is your favorite thing in the world to do, but let's keep it going. All right, so what do we have here? 4.3 times 2.2 times 10 to the 5 minus 6 power. Okay, so 4.3 times 2.2 is 946 times 10 to the minus 1. Okay, so that's that. We're done there. Now, the ratios, it's very normal, common for them not to be easily reduced, but let's see what happens. All right, so for this one, I'm going to use my very cool equation editor here. Yeah, look at this baby. Now, here's a little fun side note for you. Microsoft used to include this automatically with Word, and then they got cheap. They decided to build their own equation editor and get rid of this because they must have been paying for the license. So now the one they have is pretty terrible compared to this one. So you can still get this, but you just have to pay for it. The one they give you is kind of, no, there's no comparison. But, it's just kind of annoying that it used to be free. Not anymore. They know how to make money. All right, now here what we can do is look at it is, so the ratio of these two constants is 2.0, and then we've got 10 to the 4 minus 2 power. So you end up with 2.0 times 10 squared. And that's it. That worked out rather well. All right, how about this one? Once again, we go to the cool equation editor. 9 times 10 to the 6th. And 3 times 10 squared. Well, it's pretty clear that 9 over 3 is 3. And then we have in the exponent 6 minus 2. Oh, did I make a mistake? Oh, your pencil is your cool equation editor. Yeah, that is the original equation editor, that's for sure. In fact, yeah, it's like if you look at all the equipment in your kitchen, a lot of that stuff has only been around for a few decades. Prior to that, people always did everything with their hands. And so after a while, we tend to get a little spoiled by the technology, don't we? Yes, we do. But yeah, you know what? It's good to know that it's there if you need it. This saves me a lot of time, that's for sure. But yes, the pencil will do the job too. That's right. All right, so yes, oh, so this is going to be 10 to the fourth. So if you're using the pencil cool equation editor, you don't have to type or anything. Just write it out by hand and you're all set. Oh, whoops. No. Of course, the other thing too about the pencil is that if the power goes out, you can still use the pencil. So it always has that advantage. It's like we lost our power during the summer, if you recall. And, high technology, you notice how vulnerable you really are to it because we have this Amazon hub where all our packages are delivered. But without electricity, you can't open it up. So our packages had to sit out there while they got the power going again, which meant for like a week. And that was very frustrating. Whereas the ancient times, the mailman would bring the package and put it in this thing called a mailbox. Yeah, luckily I didn't have anything that was perishable, but it literally was not possible to get the thing open without electricity. And so everybody's packages just sat there, and that was that. There's literally nothing we could do about it. So, you want to keep your eyes open. Never rely on technology too much. Okay. So it's good that you kept this equation editor going with your pencil because you never know when the electricity will crap out or the internet will crap out or something will go wrong. All right. That's my piece for today. Anyway, let's try this one. So it just means use technology, but take it with a grain of salt. You know what I mean? Don't completely depend on it. It's like with MapQuest. Like GPSs are great, but sometimes they can get a little squirrely, and so sometimes it's good to also have MapQuest printouts with you when you're driving. Okay, so we have this ratio now. Here we go. This is what I was referring to earlier. Finally, it happened. We have 0.6 times 10 to the minus 2. I'm glad this happened, but I wanted you to see this one. Minus 2 minus 3. Now, I'm going to leave it like this for a minute. Minus 0.6 times 10 to the minus 5. But, as you know, this is not proper scientific notation. That's right. I don't need to save this. This is exactly what I was telling you before. In this case, the leading constant is too small. So what we're going to do to adjust for that is multiply the constant by 10, but that means we have to now multiply this by 1 over 10. Or if you prefer, you can write it as 10 to the minus 1. Actually, that might be quicker and easier. And so now we end up with 6.0 times 10 to the, not the minus 5, but to the minus 6. Oops. Okay, so yes, that can happen too. But again, it's just a question of multiplying and dividing. Make sure you do it carefully, but just, you have to correctly choose what you're multiplying by 10 and what you're dividing by 10. And when you're done, you want to have it, again, a single digit for the decimal, followed by what happened to this one? Wait a minute. Did something go wrong here? Oh, I made a terrible mistake here. Did you notice it? I was typing too fast. This is minus a minus 3. Oh, jeez. That was dumb. Yeah, so you see, you've actually got 1 here, positive 1. Yeah, it's so easy to do that. You see, the problem is when you have a negative in the denominator, you're actually subtracting a negative number. So this is actually 2 plus 3. Yeah. Let me put this in here separately. Oh my God. Well, luckily, it's easy to edit with this thing. Yes, it is. So that means that this one was here, and so I have 0.6 times 10 to the first, and now I'm going to multiply the constant by 10, and I am going to multiply this exponent. Here I've got 10 to the minus 1. So instead of 6.0, I've got 6.0 actually times 10 to the 0, which means it's 1. So you can leave it like that, but this is just 6. It would be kind of weird to have scientific notation with 10 to the 0, but technically that's correct. All right, so now it works. All right, that was bad. That was close. I almost screwed it up royally. So there it is. It's correct now. Because, yeah, that subtraction of a negative number. Okay. Yes. I know, it's amazing. And it's usually the silliest little thing. It's not the complex parts. It's the ridiculous parts that we tend to screw up on. It must be that somehow your brain just says, oh, this is hard, I better focus. And then when you get to the other parts, it says, this is easy, don't worry about it so much. And then this is what happens. Yeah, it makes a big difference, doesn't it? So that's that. All right, so now the next one is another ratio. We got two more ratios, then we can switch our attention to sequences. Okay, so we've got (6.4) times 10 to the 8th. Down here we have 8 times 10 to the minus 2. So we're gonna have to be careful again. Look at that. There's a minus in the denominator. So here we have 0.8 times 10 to the 8 minus a minus 2. See that? We're gonna have 0.8 times 10 to the positive 10. And guess what we have to do? Yep, it's not quite ready. We have one more step. We're going to have to make some adjustments here. 0.8 times 10 to the 10th. We don't want that 0.8, do we? We want 8. So here's what we're going to do. We're going to multiply by 10, or 10 to the first, and then we're going to multiply by 10 to the minus first to make sure we don't change the value. Eight times 10 to the 9th. Okay, and then one more. All right, so we've got, actually, here's one of the nice things about this. I can just edit this without starting all over again. Woo-hoo. Well, that's a time saver. All right, 6.6 times 10 to the third, 1.1 times 10 to the fifth. So we're going to have 6 times, or 6.0, I should put it, times 10 to the 3 minus 5. And so this is a nice, easy one. It's just 6.0 times 10 to the minus 2. Oh, wait a minute. Oh, it's being a pain. All right, that's it. We're done. Yeah, that one worked out well. We didn't have to make any adjustments. Okay, so now we're ready for some sequences. Sequences are kind of cool. So here's what we're going to do for each of the following sequences. And I'm telling you right up front, they're arithmetic. We have the following request. What are the first 5 terms? What is the 12th term? And what is the sum of the first 12 terms? Now you notice how they're not actually giving you the sequence. Instead, you're being told the starting value and the common difference. So what you can do, or you might want to do, you don't have to, but you can visualize it just by writing them out yourself. And that might help avoid making mistakes. For example, if you look at 37, this is 1, 6, try that again. 1, 7, 13, 19, 25, 31, 37. Okay. How do you know that? Because A1 is 1, and then after that, you just keep adding 6s to go to the next term. So already you know the first 5 terms. Okay, 1, 7, 13, 19, 25. The 12th term, you've got 2 options. You can write them all out. You can just carry on. Let's see. Okay, just literally keep writing them, or we have a special formula for this, as you recall, which goes like this. AN equals A1 plus n minus 1 times d. Now, you already know what these numbers are. They were given to you in the problem. So therefore, A12 equals 1 plus 12 minus 1, 6 equals 1 plus 11 times 6 is 1 plus 66 equals 67. What a surprise. No, not a surprise, because that's exactly what we got when we did it by hand or manually writing them all out. And then we need the sum of the first 12. Okay, something happened up here. Let me fix this. Okay, so you got the first 5 terms, the 12th in 2 different ways, which isn't absolutely necessary, by the way. And then the sum of the first 12. Now this one, you probably should use the formula because it is a bit of a mess to do it by hand. All right, I'll do this for the equation editor. It's a bit of a mess. Sn, the sum of the first n terms, equals the following ratio. N times A1 over 2. And in this case, might as well keep going. Sn, oh, what's this? This is something I can't do on the whiteboard. What I'm going to do is just basically recycle this 12, because it's 12 terms that I'm looking for. The first term was 1, and we've already determined that the 12th term was 67. Oh, okay. And that turns out to be, you can simplify it a little, 12 times 68 over 2. And that turns out to be 408. And that's it. You're done. Now you can confirm that if you want to, but I think you'll agree that this is the way to go. I mean, come on, you're going to add up these numbers. Not a single mistake. I don't know. That's going to be hard to do. This is easy. But you can certainly feel free to double check it if you want to. Or you can use Carl Gauss's approach. If you notice, you've got 6 pairs of numbers, each of which adds up to 68. Ooh. So if you just multiply 6 times 68, you'll get the same thing. How do you like that? All right. Now 37, B, that is. Oh, no, wait a minute. What do we do here? Yes, 37 ABC. So 38 is this one. You know what? Let me do this. Let me move these out of the way. That's probably better. So this way you can start by writing them out if you want to. But remember, we only need the first 5. Then you look for the 12th term, and then you look for the sum of the first 12. All right, so we'll do it that way each time. So for this one, we got 10, 15. Oh, this one is easy. In fact, it's so easy, we may as well figure out what the 12th term is just by writing them all out. So one more. All right, 65. All right, so first things first, what are the first 5 terms? Very good. The 12th term can be calculated from this formula, as always. And then you get A12, 10 plus 12 minus 1 times the common difference of 5, which is 10. Uh-oh, did we do something wrong here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, that's it. No, we got it right. Okay, good. And of course, we've already seen that that was true by writing them out. And then C, I'm just going to recycle this equation because I can. That's kind of nice. So the only difference here is that the 12 is still N, and it's still 12, but the first term is 10, the last term is 65. So I've actually got this time 12 times 75 over 2. And that turns out to be 450. All right. All right. Now, let's try this one. Now, this one's looking tricky because it's got a lot of negatives. So we start with -9, and then we're going to keep subtracting as we go along. Let's see, is that all of them? 1, 2, 3, 4, 5, 6. That's good. All right, so for part A, we need the first 5 terms. Okay, then we need the first 12, or sorry, the 12th term. Although we do already know what it is. Let's just use the formula. Okay, so we'll have A12 equals, the first term is -9. We're looking for the 12th term, and the common difference is -3. And it's -42, and we already knew that. Nice. And then for C, well, I'm just going to recycle this formula. The only thing that changes is the first and last terms. So here we have -9 as our first term. The 12th term we've already seen is -42. So we got 12 times -51. And that's going to give me -306. Okay. Very good. All right. And I think there's one more, isn't there? Yes. Okay. Now, of course, we've already had one with 2 negatives, so it won't be that scary. Let's find out. So this is actually -15, -17, -19, -21. Let's see where it stops. That looks like 12, right? 1, 2, 3, 4, 5, 6. Yep, that's it. All right, so for A, as usual, the first 5 are these guys. The 12th term, we already know it, but we'll use this formula just to confirm that. All right, so that means that A12 is -15 plus 12 minus 1. The common difference is -2. What do you know? -37. Okay, no shocks there. And then finally, the sum of the first 12, I'll just borrow this equation. Yeah, sometimes it gets sluggish. I don't know what's going on. But anyway, so we just need -15 minus a -37. God, we got to be so careful with those negatives. Those oh no, sorry, my fault. This is a plus. No. I'm thinking of the wrong thing. It's plus -37. Or you can simply rewrite it as, okay, that's right, because this formula asks for a sum, not a difference. So we were fine in the first place. So so that means this is going to be -52, it looks like. Oh, it's only slightly different than the last one. -312. Now for these, we're going to change our approach a little bit. We're going to, instead of giving you A1 and D, we're going to give you the terms. And now you have to figure out for yourselves. So like for this first one, the first thing you might want to do is just identify, move this down here, identify A1 and D because you're going to need them. All right, so here you were just given, not the sequence, but A1 and D. Here it's the other way around. You have the sequence. So for example, here A1 is clearly 5. And the common difference is 8. And if you want to stretch this out, you certainly can. In other words, you might say, well, you know, I'd really like to figure out the 12th because this time it's the same basic setup. You need the 12th term and the sum of the first 12. So let's try that. Let's just keep going. until we get to what we're looking for, which is the 12th one rather. Let's see, is that it? 1, 2, 3, 4, 5, 6, 7. Oops, I made a dumb addition mistake. 93, there you go. Let me confirm this now. There you go. All right, that's it. All right, so part A in this section is the 12th term. So A12 is, we may as well use the formula. We can see that it's 93, but let's use the formula. Just in case, instead of the 12th term, it's like the 500th term. Something you don't want to double check. Let's just say we don't want that. That's too much. So you have 5 plus 12 minus 1 times 8. 5 plus 11 times, that's right, 5 plus 88. Yes, perfect. 93. Now, what's part B then? I recognize this. It's the sum of the first 12 terms. Let's grab this thing. All right, so here it's 12, but now the terms are 5. The first term is 5. The 12th term is 93. So you've got 12 times 98 over 2, which turns out to be 588. And that's it. Okay, so we only needed 2 things, the 12, because you already have the first 5. There's no point in doing that again. So instead, you're just doing the 12th term and the sum of the first 12. All right, beautiful. Now, this one, A1 is clearly 2, and the difference is 10. Good. So why don't we carry this out a little further? Is that 12? 1, 2, 3, 4, 5, 6. It is indeed. All right. So here we're looking for, well, we already know it, but let's use the formula. And we'll get A12 is 2 plus 12 minus 1 times 10. 112. No surprise. And then let's grab this formula. I'm editing it or recycling it, I guess we could call it. So now the only thing I have to change is the first term is 2. The 12th term is 112. And so here I've got 12 times 114. And that's going to bring me to 684. Uh-oh. I see some scary ones coming up. Oh boy. All right, well, with this one, A1 is 50 and D is -2. So if you keep writing these out, is that 12? 1, 2, 3, 4, 5, 6. So in part A, we'll use this formula again. So therefore, A12 would be 50 plus n 12 minus 1 times negative 2. 50 plus 11 times negative 2 is 50 minus 22. 28, very good. And then the sum of those first 12 in part B, again, we'll grab this formula. Yes, this is it. That's the way to go. All right, so here, I've got to change the first and the last terms to 50 and 28. And so we've got 468. All right, now what's going on here? Now, if you look at it, you might say, well, I don't get it. Here's a helpful hint. Why don't we convert these all into a common denominator? All right, so if I do that, for example, 1/8 is actually 3/24. How do you know that? Then we'll have 19 over 24, 35 over 24. Oh, here we go. 17/8 is the same as 51 over 24. Then we have 67 over 24. So now it should be more obvious what's going on with the sequence. A1 is 3 over 24. Let's leave it like that. Don't reduce it. And then the common difference is 16/24. Okay. So I'm going to borrow this. And let's write out the first 12. And we just keep adding 16 over 24 rather. So for example, this next one would be 83 over 24. And then we're going to have 99 over 24. Oh, you know what I realized I wanted to change these too. Okay. That way it'll be more obvious. All right, now we're good. Okay. Let's see, we need a few more. 115 over 24. 131 over 24. Yeah, we got a ways to go here. 147 over 24. 163 over 24. Let's see, how many is that? 1, 2, 3. And one more. That should do it. All right, so that's done. What a headache that was. All right, so now, remember the first part asks for the first 12 terms, or the 12th term rather, but let's use our formula, even though we already know what it is. So we'll have A12 is 3/24. That's 12 minus 1 times 16/24. Oh, it's proving not to be as difficult as it looks. Hold on. Okay, because all we have to do here is this, 3/24. If you now keep in mind, this is implicitly 11 over 1. And so I can multiply the numerators and I can multiply the denominators, and this is what I get. And so I end up with 179 over 24, which is exactly what we have. Now for the sum formula, we're going to have something that's kind of messy. That's all right, we can do it. Except now, man, look at these numbers I have to deal with. I've got 3/24 here. Actually, let me fix this a little. Actually, and yeah, here we go. 3/24 plus 179 over 24. Ooh, man. So I've got 182 over 24 here. So let's see what that reduces to. Ooh, we have 12. So in the numerator, what I can do is I can simply write this as so I'm going to wind up with 12 times 182, 2184 over 24 over 2. Now, this is the equivalent of this. Watch this. And so I'm doing it this way for a reason, because what I can do now is multiply this by 1 over 2. All right. Since I have 2 over 1 in the denominator, dividing by 2 over 1 is the same as multiplying by 1 over 2. So I've got 2184 over 48. Now, it should be possible to simplify this a little. It works out to be, oh, here we go. It turns out they both have 24 as a factor. So if you divide the numerator and the denominator by 24, you'll get 91 halves. Or if you want to write it out as a decimal, 45.5. Yeah, little sloppy there. Wow, what a mess that was. All right, I'll tell you what, there's one more arithmetic sequence, then we can save the geometric ones for next time. And the dreaded word problems. And then when we're done with that, we'll carry on with chapter 6. Okay. There's no rush. We didn't have to finish this today. But for this one, you can see this one is easy to transform into a common denominator. All I have to do is rewrite 1/2 as 5/10. And it's easy to see that A1 is 5/10 and the common difference is 4/10. All right. So if you were to continue to write them out, looking for that 12th term, look how easy it is. Oh my God, we got a ways to go here. I guess I'll have to spill over onto the next line. That's okay. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. All right, so we can use the formula, even though we already know what it is. Not a problem. So the first term was, remember, we'll write it as 5/10. And when we're done, we'll see that we proved that we had it correct up here, 49/10. And then finally, we'll just do the sum of the first 12 and we'll be done. Let's go grab that formula. All right, so again, the first term was 5/10. We can put that in very easily. The last term was 49, 49 out of 10. So we have 12 times 54/10. All right, let's see if we can clean that up a little. So 12 times 54 is 648 over 10. All right, I'm sure this one can be simplified too. Let me neaten this up a little. Let's see. That one turns out to be, oh, not as much as 162 over 5. Well, that's not so bad, which is 32.4. Oh, these ads. All right, so yes, like I said, since it's 10 o'clock, let's just stop here. We'll save the rest of it for next time. It won't take that much longer to finish it. We've got a few geometric sequences and some word problems, and then we can get back to chapter 6. So your job in the meantime is to make sure you understand what we've done and then finish the rest, and then we'll take it from there. All right, any last minute questions? I'll tell you what I'll do too. I'll post the partially completed solutions here so that you can look at them between now and Thursday in case you missed something. All right. Anything else? All right. If not, I'll see you all on Thursday.
Thank you, Professor. Have a nice week.
Thank you.
Okay. Bye.
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 See you later.